My name is Benjamin Eastman, and this is the history of Intel CPUs. The beginning. The CPU abbreviation stands for Central Processing Unit, as it serves as the brain of your computer. The first commercially produced CPU, the Intel 4004, was invented in 1971 by an Italian physicist named Federico Faggin, working for Intel. The 4004 was a 4-bit processor and had a max clock speed of 740 to 750 kHz. The 4-bit processor family. The Intel 4040 chip was developed shortly after the 4004 and served as its successor. The 4040 was introduced in 1974, offering a few more features and changing the socket type. Intel only ended up making two 4-bit CPUs, the 4004 and the 4040. The 8-bit processor family. Intel's first 8-bit CPU was the 8008, which was developed alongside the 4004. It had a clock speed of 500 kHz. Intel's 8080 and 8085 CPUs were developed a few years after and had significant clock speed improvements as well as more transistors. This leads to Intel's microcontrollers. Microcontrollers are basically mini computers that have a CPU, memory, and programmable input-output peripherals. Between the 8-bit and 16-bit processor family developments, Intel introduced over 20 different microcontroller chips. In chronological order, the first was the Intel 8048, and the last in the series was the 80296. This leads to the 16-bit processor family. Intel introduced their first 16-bit processor, the 8086, in 1978. This processor ran at a max clock speed of 10 MHz with a data width of 16 bits. This CPU gave rise to the x86 instruction set architecture that is still used in most computers, like mainstream computers nowadays. Now the 32-bit processor family, the non-x86. Intel's first 32-bit non-x86 CPU was the IAPX 432, which was introduced in 1981. These are the first CPUs that have more of a visual resemblance to the CPUs in our computers today. The picture shown is of the i960, which was another non-x86 CPU released in 1988. The 32-bit processor family. This family of processors starts with the 80386DX, which was introduced in 1985. This family of processors encapsulates thousands of overall improvements as well as many socket changes and spans over 20 years. The Intel Pentium chips are probably the most well known from this generation of CPUs. The fastest and latest CPU from the 32-bit family was the Pentium 4E with an 800 MHz system bus and 169 million transistors on the die. This chip also had a 90 nanometer process technology. The nanometer process. Reducing the size of the transistor process was and still is an important part of making faster CPUs. With a reduction in size, these manufacturers can pack even more transistors onto the CPU die, allowing for speed increases and other overall improvements. The 64-bit processor family. Intel's first 64-bit CPU was the Xeon, codenamed Nocona, introduced in June 2004. The Xeon Nocona had a single CPU core and ran at a max clock speed of 3.6 GHz. The next major improvement for the generation came with the Xeon Woodcrest in 2006 with its 65 nanometer process technology. In December of 2006, Intel released the Xeon Clovertown, which had 4 cores on a single CPU die. This was a huge leap in processing power for the CPU. Intel's core generations. With the introduction of the Core i3, Generation 1 in early 2010, Intel began organizing their CPU releases into generations. As of today, Intel is now on their 10th generation of CPUs. The most current CPUs are in the Core i9-10 series. The generation is determined by the number right after the I number. For example, in my computer, I currently have a Core i7-8600K, which is an 8th generation CPU. The newer generation CPUs are generally more optimized and energy efficient, as well as just being overall faster. The first generation Core i3 CPUs were first introduced in January of 2010. They utilized a 32 nanometer process technology and could reach a max clock speed of 3.3 GHz with the correct variant. This dual-core CPU also introduced hyper-threading, which is now a common feature in newer CPUs. I think I saw a statistic somewhere that was maybe like 70% of all CPUs, all present CPUs have hyper-threading. Intel Core i5s. The first generation Core i5 CPUs had two main variations, Linfield and Clarkdale. Linfield had a 45 nanometer construction, whereas Clarkdale is just 32 nanometer. The Core i3 also utilizes the Clarkdale infrastructure. The main changes from i3 to i5 was the doubling of the cache size from 4 megabytes to 8 megabytes, and also adding 2 more physical cores. The 1156 LGA CPU socket also remained the same from i3 to i5. The Intel Core i7. The first generation Core i7 CPUs had 4 variations: Bloomfield, Linfield, Gulftown, and Clarksfield. The Core i7 also had an updated CPU socket change to the 1366 LGA type. The Gulftown variant had up to 6 physical cores with 12 megabytes of cache, as well as the feature called Intel Turbo Boost. This feature could overclock the CPU to a max clock speed of 3.73 GHz. From Nehalem to Bridge. Intel introduced new CPU architectures with the release of the Intel Celeron and updated Pentium chips. These architecture upgrades were instrumental in accelerating the advancement of CPU speed. The first generations used an architecture called Nehalem, which was surpassed by the updated Bridge architectures in generations 2 and 3. For example, the Core i3 second generation utilizes the Sandy Bridge architecture. Smaller and faster. These optimizations and upgrades continue for about 9 generations to present today, where the next generation CPUs aren't massive improvements over the previous generations. The speed increases are slowing down, but that is to be expected when Intel and other companies are trying to get closer and closer to the bounds of the laws of physics right now. This is where the Moore's Law debate begins to take place. Do you think the rate of improvement will continue? Personally, I think it's about 50-50 if it's going to slow down significantly or speed up, but that's just my opinion. Here are my references and sources, and thank you for listening to my presentation.